I'm planning to talk about in this talk kind of some good practices to apply to when you're creating an Angular application, right? I'm not going to go into great detail on like everything you need to do to make one, but hopefully by the end of this you should know basically some of the things that we learned when we were making an Angular application. So you don't have to learn the same lessons the hard way. So this is what me and a few other people on the Angular 2 team built at Lucidchart. So the actual internal, like the canvas, like where you see the chart and diagram, that's all existing code. We just built a new UI that goes around the outside, and we did that over the course of like 6 months. Well, it's still kind of in some development going on to it right now, but it took a chunk of about 6 years or 6 months, sorry. And we started on the we were working with Angular back when it was in beta, so we kind of were with it and kind of transitioning to these different phases. And the first thing with Angular is right now TypeScript's your best option for a language. I mean, you can get Angular working with just plain JavaScript, which would mean anything that compiles to JavaScript, you could also use that in theory. But you get a lot of great tooling when you use TypeScript. And over time, I'd expect for some of the popular languages to also develop similar tooling. But for now, TypeScript's probably your best bet if you want to be making a new application. If you need to make it compatible with an existing one, you can. But it's just you have a little extra work there. So, the great thing about Angular is it lets you create components, which is kind of like a custom HTML element. So, for example, some of our components, like the kind of see that little margin page, these little sections you can expand and collapse. You can just create a single component that you want to be an expandable or collapsible section. You give it some content, and bam, now you have a little button you can push to expand and collapse content, or a color picker. You just if you want to be able to choose a color in your application, you just say I want a color picker here. Just as easy as you would say I want text input. And so you can build out these modular components into an application. And just a quick example of a component. Sorry if you can't see that so well in the back, but so the nice thing about Angular components is they're very upfront about how to use them. In the component annotation on the top, you give it a selector of what you want the name of your custom element to be. You can annotate inputs and outputs, and you can see very clearly in the TypeScript where the inputs and outputs are, what they're named. And so when you go to use them in an HTML template, you have that kind of one-to-one mapping there where you can see very clearly how to use it. And then if you're looking in the HTML template, you can see very clearly what inputs and outputs you should expect on that component. The same thing goes with when you're using your template. You can see kind of that toggle open function in there. And that toggle open is used or is defined in the component here in your TypeScript class. So anything you define on the class is available to you in the template and nothing else. And so it's very clear what you should expect to be in your available in your template. And there's not going to be any hidden tricks like if you've ever worked in Angular 1. Sometimes you could really pollute scopes in Angular 1. I feel like you can start adding things that really shouldn't be there, and creating a component one place could inadvertently affect another. Well, in Angular 2, you have a very easy to see binding between those. So it's I like to say like the components are very upfront about what they do and how to use them. And that's the first thing is I want to get to is just keep it that way. When you're creating these components, you want to make sure that the way you use them is very clear, and that their state should be based on their inputs, right? So you can kind of think of that kind of like functional programming. It's this is very clear. Your TV. In order to get your TV to work, you plug in these little components here, these little plugs, and you don't have to like do some sort of like magic thing with your Blu-ray player in order for the TV to get the signal. It's just those inputs. And so you think about you want to make your components that same way. And an example of something you could do to not do that would be having global state. If you have global state in your program, like let's say that color picker, you decided you want to have a list of common colors, you make that a global variable. Well, now you have global state in your program. And the way then that component won't behave based on the inputs. And you can kind of think of this as like functional programming, but with components. And so as you start building these small reusable pieces, you can start combining them together into larger, more functional pieces, right? So you have little form components that you, like an input, or you have a color picker, a date picker, and then you can combine those into like a form. And the forms you can combine into your larger applications. And so this little piece by piece, going up the layers, you start building a more complicated application. And so you kind of want to try to keep things modular, and you don't want to do this, right? You don't want just like, if you need a global, you need to access something, you create a global variable, and you write that global variable and you pull it some other place. And even without using globals, using a dependency injector, there's still ways you can abuse that, right? Like where we don't want to be injecting data that you should be making inputs, right? A component should be, again, I'm just going to reiterate, component state should be based on the inputs, not on some sort of hidden state that you can't see. So yeah, now getting to the injector. And so Injector is a beautiful thing about Angular 2. It makes handling kind of this larger applications very nice, where you can just kind of grab the little pieces that you need, the injector gives them to you, and components and other parts of the application only have to really worry about a few related parts and not having to like this big mess of like global state in your code. It really helps reduce and solve that problem with global state. And here's just a simple example of how you might be using an injector. So let's say you have the login service here, where its job is to log you into your application, right? You can go to a website, you can log in, it will authenticate, and then you create a login form over there. Well, with Angular, all you have to do is you just annotate your login service is injectable. And so that lets the injector know what inputs that this component has. And by inputs, I mean like their constructor, right? So anything that you have in your constructor is now injected in. So in this case, the injector would also have an HTTP client available to it. And so whenever so the login component, when it says, hey, in my constructor, I need a login service. And so the injector will go and say, okay, well, it needs a login service. It checks, okay, I haven't created one yet. It goes to create it and says, okay, but now it needs an HTTP client. It creates that, passes it in through its constructor. So you create the login service, and now the login service is constructed, and it passes that into the login component. And then everything in the injector that is created, it's remembered, right? So the injector will reuse that component if it's ever requested again. And there are ways to get multiple if you need it. It's just like, for example, a component could say, hey, I just need my own instance of whatever class, and it will create a new instance for that every time. I'm not going to go into detail about that, but the injector is a very, very elegant, simple way to pass dependencies around, and it makes creating applications simple and then very testable, which is an excellent plus. Anyway, so yeah, you can see kind of how the injector might be working in this case. And the way the injector knows about what parameters you're getting is just by those annotations. So you see where it says injectable on this side, and over there in component. When you add that into TypeScript, it adds what's called decorators to the class, and so now it knows the types for the inputs, and it's a very good way to programming. It kind of encourages clear dependencies, and I definitely recommend following a good pattern. It's called dependency injection, where you just kind of keep your dependencies clear. And if you're doing this, then your dependencies in your program will follow will be an acyclic graph, right? And it makes sense because you can't have two classes depend on each other, right? Because at least both being passed in their constructor, right? You create a class and you pass it into the constructor A. Well, you can't then take that class B and pass it back into the constructor of class A. And so you kind of get this acyclic graph, and that goes back to it. This leads me to my next point I'd like to make, is that don't add cyclical dependencies into this graph, because it just makes your code makes it a little more fragile, like it's not as reusable. So suppose suppose I did add that implicit arrow back. And you could do this by, for example, you could take class 0, inject it into class 3, and then inside of the constructor of class 3, you can say class 0 dot init, and then you pass yourself to it, right? You can do that. That's a way you can add that cyclical dependency, but I advise against it because now, suppose you're making your application and you want to, you don't need 3 anymore, right? And you only want to reuse 2 in that graph. Well, what's going to happen? If 0 depends on 3, it's not a clear dependency. And so you'll construct 2. It'll go construct a 0 and a 1, but 0 will be incomplete because it implicitly depended on that 3, and it's not going to be there. So keep those cyclical dependencies untangled. Keep the dependency graph a single direction. Have it flow one direction. And so that's a piece of advice there. And then also so I've talked about components and the templates that you get with them, and then anything you can inject in, like the login controller or login service or anything else you can consider part of the model. And that's kind of, if you're familiar with the model controller view pattern, you can kind of apply that to Angular if you want to think about it that way, where you have your view, which is the template, component source, which is the actual thing annotated with component, and then anything in the model is injected. And just like with model view controller, with Angular applications, you want to keep your views slim. So you don't want to add a bunch of logic into the template. Because it does let you write basically JavaScript in the template. On any of the inputs or outputs, you can write JavaScript and have it do complicated things. But you don't want to do that. You want to keep those views very slim. And the controllers, you also want to keep fairly lightweight. You don't want a bunch of business logic and important logic in the controller or those components in the case of Angular, because oftentimes you might want to reuse that, and if it's tied to a component, well, you have to either, I guess at this point, you'd refactor the code. You'd move the logic out into a common model object, some sort of non-component that you could just dependency inject into any component that needs that behavior, right? And so that's kind of a good way to kind of go about making these applications, is keep your view slim, your model thick, you have all the business logic in the model, and your controller is just kind of like the glue between the model and the view. And also, there we go, okay. And another piece of advice I'd give with Angular is just avoid inheritance. It's not to say outright ban it, but this comes from an example when we were working in the application using the dependency injection of something that just became a huge pain point. And it's this. So suppose you have 3 classes, B extends A and C extends B. So you kind of have this, 3 layers of inheritance going on. And A has no dependencies, B, you have 1 dependency, C, you have 2 dependencies, right? And so what happens when you need to add a dependency to class A? Well, you can see over on this side what that does. Now you have to go in every single subclass of A and all of its subclasses and add that dependency in, right? And it quickly becomes a huge pain when you have class A may downstream have like 12, 30 subclasses. If you're making heavy use of inheritance, anytime you have to add these new dependencies, it just explodes out, and you have to add this. It just becomes busy work of just adding that dependency everywhere and passing it through. So that's an example there where it becomes painful to be using the dependencies. And another thing with inheritance is, suppose in the dependency injector I provided a class C, right? You'd expect to be able to say, okay, well, I want class A. In the dependency injector, you might expect it to think, okay, well, since C is actually a base class of A, I can just give him this, but it won't do that. It'll say I don't have an A. So you actually have to explicitly specify every single level of that inheritance tree of what you want the injector to give you. And again, that's not too painful, but it's just kind of a little kind of unexpected quirk. And then you start doing that, And well, now if you say, okay, well, I want class A, but sometimes you make assumptions in the component saying, okay, well, I injected class A, but really I know it's a class C, so I'll just cast it to a class C. And it just starts to become messy, and again, there's just a few of the pain points that we found with inheritance. Again, I'm not saying you don't use it where it makes sense, but again, just favor composition in kind of these situations. So an example would be maybe C doesn't extend B, instead you inject B if you need functionality from B, and same thing from B to A. And so now if you can add a dependency to A, and the injector will automatically handle that for you, and you don't have to change the constructors on B or C. And one thing about inheritance is you don't actually need it. There are ways around using inheritance in many of the situations you get it. I mean, and this is excluding like kind of interfaces or abstract classes where you kind of define like a common interface and then implementations of it. When this is just what I mean is like don't be using inheritance just to reuse code. That's a no-no. So. And so examples here of kind of where inheritance, so at one point in our application we're using inheritance to do pop-ups, right? So that pop-up over there where you have the little button, all those buttons in the group, if you wanted to have something pop up like that, you would extend a class. We eventually found that was kind of painful, and a better solution would be just to create a component that'd be an overlay class. And you could then you can toggle the overlay on and off, specify where it's anchored to, and then the content of that overlay becomes the content there. So you don't have to be extending constantly. And just think about it like that, where you create these small reusable pieces that you can combine together in useful ways. Don't be extending to get the functionality, right? And also, kind of going back to that, or going alongside with that, is you want things to have a single responsibility. You want components to do one thing and do it well, and you don't want to be making this, right? It's much less useful, much less reusable. Instead, you just want a few useful tools that do what they do really well. And oftentimes, another thing you want to do in single responsibility is suppose you have a kind of dependency graph set up like this. You have 3 components, 1, 2, and 3, and they all depend on a common object, like a service or something in 0. And now suppose we want some functionality for both 1 and 2. Big temptation would be, well, they already inject 0, let's just add it there, right? But if it doesn't actually relate to 0's functionality, then you just end up with, like the God object in a class. I mean, we probably all have seen code bases where you have these classes that are thousands of lines long, and they have all this unrelated functionality in it because you get this. You want to add functionality, and you just add it in the most convenient spot. But take the time and split out the dependencies. With the injector, it makes it easy. You can just create a class for. You say, hey, I need one of these in my application, and 1 and 2 now depend on it. And the injector takes care of the rest. So be sure that to be doing that right. The injector makes it easy. You don't really have an excuse to not be doing dependencies right. And also single responsibility is this kind of goes back to the cyclical dependency, but also make sure that when you create these small reusable components that kind of do their one job, that they work in many contexts, where they don't have to be inside of be used in a specific way to actually work. And I kind of use the example of a login screen here. So suppose you have your normal login screen, and you get the design from that you have to implement, and the way you code it is that the view has a fixed width, because in that single design, like, okay, whatever, it has that one width, or it's going to be flowed, or it's going to be set up in a certain way. Well, now if you want to create this drop down, and maybe the width is a little bit different, well, now it's you kind of made an assumption about how it's being used, and that is kind of a cyclical dependency. And again, you want to break those where you can. You don't want to have to depend. You don't want your components to only work inside of a single component, right? You want it to be able to work where you happen to put it. And the last little bit I want to talk about is change detection. And if you're familiar with Angular 1, then you can kind of understand like the whole like digest cycle, where you make changes in your code, or you make changes in the data that the application has, and it'll loop through all your components and check for changes. And if there are changes, it updates your view. Well, Angular, if you're familiar with Angular 1, you may know about this thing you have to do called scope.apply. When maybe there's some changes that were made that Angular doesn't know about, you have to tell it, hey, there were changes, now go update everything. Well, Angular 2 has gotten rid of that by using this really powerful feature called zones, where it's basically gone through and hijacked any sort of asynchronous event the browser may have, and anytime those events happen, it knows which zone those events happen in. So for example, you start a zone, you kick off a set timeout. After the set timeout finishes, when it calls that function, it still knows which zone it's in. And so since it knows which zone it's in, it can also run code when it enters or leaves zones. And so you have an Angular 2 zone. Anytime the JavaScript enters or leaves, or anytime the JavaScript leaves a zone, or basically finishes an asynchronous event inside of a zone, it will know to update, do any update any changes. It'll know to run the change detector, and contrast that with Angular 1, where you have to inject specialized like timeout objects or specialized HTTP objects that will trigger the change detection for you. In Angular 2, it's basically just kind of invisible, which means though, if you have a really big complicated application like that we were dealing with, that's a lot of stuff to go through and check for changes on. And it was taking, I think, about 8 milliseconds per change detection cycle. But if it's doing that for every mouse move, for every timeout, for every network request, that adds up pretty quick. And you'll have running that multiple times every second. So what you can do, if you're building a large application, which I guess my talk is making it scalable, which we want to do. We want to make it large. You want to, this is just the performance of so all of those like little, you can see kind of those like light blue sections out there. Each of that is a change detection being run. You can see it's just happening constantly. And so what you do is if you mark your components as change detection on push, then it won't run the change detector on components unless their inputs change. And so, in this case, suppose all of those are change detection on push. When it runs the change detector, it'll go to the root application and say, oh, nothing changed. No, nobody's inputs changed, it'll just be done. And it can skip a lot of work. But the problem now is that suppose an asynchronous event happens down here, it won't get there. It won't get the change detection because no input changed. It was just an asynchronous event happened and something changes in the component. So that's where you need to then say, you inject the change detector into your component, and anytime you get any of those changes, any asynchronous event happens, and you need to update the view, you just say change detector mark for check. And then what that'll do is say, okay, well, I have changes, I need to be checked, and then it'll go to its parent and do the same thing up until it gets to the root. And so then next time the change detector happens, you can say, oh, there are changes, I need to do the change detector, check its children, oh, this one changed. It'll check its children, and then it'll finally get down to here, and it'll update and respond to those changes. So that's just something to keep in mind if you're writing a large application. You want to be doing that from the beginning, because going back after the fact and trying to figure out everywhere you need to do the change detection on push is a little more of a hassle. So anyway, that's basically it. Are there any questions? Okay, great. Thank you.